In this video, I will show you how to do multi-step matrix multiplication problems. Okay, look at number 12. We need to multiply AB times C. Now, remember, I already know matrix AB. All right, again, this is matrix AB right here. So let's go ahead and just copy that down. So when I say matrix AB times C, I'm going to start with 2, -1, 20, and 5. Now I really hope I did not make a mistake when I calculated matrix AB, because that mistake is now going to show up in a bunch of different problems, and that would just be heartbreaking. So there's AB. Now I need to take this and multiply it times matrix C. So let me look up at the top of the paper and find matrix C. Okay, matrix C is right here. 3, -1, 0, 5. Okay, so we've already done the dimension analysis before. It'll be the same analysis as problem number 11, because the first matrix is a 2 by 2 matrix. The second matrix is also a 2 by 2 matrix. This product will be possible because the inner dimensions are the same. Boom. The outer dimensions will tell us the dimensions of the final product. So, because the outer dimensions are 2 by 2, we know that the final product will be a 2 by 2 matrix, which is important because we need to set up an empty 2 by 2 matrix in which to show our work. Okay, let's remember that the rows always come from the first matrix and the columns always come from the second matrix. Alright, so when you multiply matrices together, you're always multiplying rows times columns. Rows from the first matrix times columns in the second matrix. Alright, I like to write down all my rows first and then all my columns. So, row 1 will appear throughout row 1. So, row 1 is 2, -1. So, it will appear in every entry of row 1. So, row 1 appears in row 1. Row 2 appears throughout row 2. So 20 and 5 will appear here and here. Row 2 appears in row 2. Now let's talk columns. Column 1 will appear throughout column 1. So 3, 0 will appear here and here. Column 2 will appear throughout column 2. So -1, 5 will appear here and here. Now we multiply and add. If I multiply, here I get 6 and 0. Add them up, you get 6. Multiplying here, I get -2 and -5. Add them up, I get -7. Multiply here, I get 60 and 0. Add them up, I get 60. Multiply here, I get -20 and 25. Add them up, I get 5. These boxed numbers represent the final product. So the final product is 6, -7, 60, and 5. Alright, for number 13, I need to do 3c minus 2ab. Let's see, so 3c, so I'm doing 3 times matrix C. Looking at the last problem, matrix C is right here on the end. So matrix C is 3, -1, 0, and 5. Yeah, okay, so that's matrix C. And I need to do -2 times matrix AB. Well, I mean, it's 2 times A times B, but it's okay if I go ahead and consider this as matrix AB. And so matrix AB is right here. It's 2, -1, 20, and 5. Okay, so scalar multiplication is very easy, and that's what we have happening here. I'm just going to do 3 times every entry. So that's simply going to give me 9, -3, 0, and 15. Alright, and I'm just going to keep the minus, and I'm going to multiply all of these by 2. So that's going to be 4, and -2, and 40, and 10. So now I just need to do this matrix minus this matrix. So I'm just going to subtract each entry. Alright, so 9 minus 4, so that's going to be 5. You know, I think I'll switch to purple because it seems like I've been using that for my final answer, and that's what this is. Now, be careful on this one element. This is -3 minus -2. Do you hear the minus negative? Minus and negative is addition. So this is really, I'll do this off to the side a little bit. If -3 minus -2 is really the same as -3 plus 2. So that's going to be -1. So I'm going to get -1 right now. Okay, always watch out for the minus and negative because you're really adding. Now I've got 0 minus 40, so that'll be -40. Now I've got 15 minus 10, so that should be 5. So this should be my final answer for number 13. Last but not least, we have this matrix word problem, a real-world application. Let's take a look. Fred earns money by doing yard work for Mr. Capri. The number of times that Fred mowed and weeded Mr. Capri's lawn is given in matrix A. Let's see. He mowed and he weeded in May and June. Okay. The amount that Fred earns for each task is given in matrix B. Alright, apparently he earns $10 for every time he mows and $8 every time he weeds. So that's matrix B. Use matrix multiplication to determine the total amount of money that Fred earned in May and June. So, matrix multiplication. Let's zoom in. We're doing matrix multiplication, so we're going to multiply matrix A times matrix B. Let's analyze the dimensions. So understand that matrix A is a 2 by 2 matrix, while matrix B is a 2 by 1 matrix. So of course this product will be possible because the inner dimensions are the same. They're both 2's. But what we also need to pay attention to is the outer dimensions, 2 and 1, because that tells us the dimensions for the final product. So the dimensions for the final product will be 2 by 1, 2 rows, 1 column. So let's set that up so we can do our work. So I'll put a line right here to show 2 rows, but I'm just going to immediately put a box around it because 1 column. Okay, now remember, when you do matrix multiplication, you're multiplying rows by columns. The rows always come from the first matrix, and the columns always come from the second matrix. Okay, so I'm going to be using these rows. So row 1 will appear in row 1. So I'm going to have 3, 2 right here. Row 2 will appear in row 2. So that's why I'm going to put 4, 3 right here. Now, column 1 will appear in column 1. Of course, there's only one column, there's only one column. But I'm going to put 10 and 8 here and here. Okay, now let's go ahead and multiply and add. So if I multiply, I'm going to get 30 and 16. Add them up, that is 46. If I multiply here, that's going to be 40 and 24. That's going to be 64. So the product matrix AB is going to equal 46 and 64. Now, this will make more sense, the meaning of it, if we label everything. So remember that the rows came from the first matrix. So we will take the labels from the rows of the first matrix. So the row labels from the first matrix are May and June. So that means we must be looking at May and June in our final answer. Remember that the columns always come from the second matrix. And take a look here. The column is how much he earned. So that's going to be the column label here. This is how much he earned. Okay? So that means he earned $46 in May and $64 in June. And I'll just put that as a little sentence here. So a real-world application, the answer will always be some sort of a summary statement. And here you go.